Hello everyone and welcome to another video. This time we're going to be talking about solving radical equations of various types. So we're going to be talking about maybe solving x plus 1 equal 3. Could be talking about the cube root of 2x minus 5 plus 1 equals 7. We could talk about x plus 3 to the 2/3 power equals 7. We could talk about square root of x minus 5 plus 3 square root x equals 1. We could even talk about some weird ones like square root of x plus 3 plus 2. We have a 3 in the front equals x. If you talk about something like that, all kinds of varying types. So today we're going to work on 10 problems, a couple of each type. Do apologize for the lateness of the video. I've been having some internet and technical issues. Hopefully they're resolved now. We'll see as time goes on. I am working on completing and updating y'all's grades. Those should be updated hopefully tomorrow. I will be at the school tomorrow, which would be Wednesday, the 22nd of April. I should be up there tomorrow. If you need to ask me any questions, I'll be there in the morning, maybe some of the afternoon. Okay, so let's get right into it and get started. First question we're going to work on today is 3 plus the square root of 2x minus 3 equals 8. And the way I'm going to do these, I'm going to do them in two-column proof form, so that way you'll have the problem in every step that I work out. I'll give you an explanation on the side, so that way you can follow along for your note-taking purposes. Main thing when solving for radicals, and this is going to be true for pretty much every problem that we do, is we want to isolate the radical, and later it'll be called isolate the more complicated radical. Okay, so I want to get this radical here by itself. To do this, I need to get rid of this positive 3 in the front, and we're going to do it just like a regular equation. I'm going to subtract 3. So now these are gone. I just have the square root of 2x minus 3 equals 5. Now, I want to get rid of the radical symbol. To do that, remember this is an index of 2. So that means I want to raise it to that same power. That way it'll cancel out. So I need to raise this to the power of 2 or square it. But if I do it to one side, I have to do it to the other as well. So this cancels with the radical. I'm left with 2x minus 3 is equal to 25. So I've squared both sides. Once I've done this, I can solve it just like any equation. Solve for x. I'm going to add 3. That 2x is equal to 28. And divide by 2. Okay, that's it. Simple. 1, 2, 3, 4 steps. Now, number 2, you should try to work out this one now that you got the steps. You should try to work this one out. Once I get it up here on the screen, we're going to do 4x plus 1 minus 5 is equal to 0. Set up my two-column proof format. Now, you do not have to do the two-column proof format when you're solving your equations. I'm only doing this for your note-taking, so you have steps to follow on how to do it. So I'm going to pause the video. You should pause the video for a second, work it out, and then come back. All right. Hopefully, you've paused the video and worked out the problem so you can see the solution. I'm going to go through the steps. First thing, get the radical by itself by adding 5. Square both sides. I'm just going to put x squared for squaring both sides. Or actually, better yet, I'm going to put radical squared. Okay, solving, subtract 1. And divide by 4. So I should get x is equal to 6. Now just a quick check, just to make sure we're getting the right answer. I'm going to take 6, plug it in. Okay, so 4 times 6, that's 24 plus 1. 24 plus 1, that's 25. Square root of 25 is 5. And 5 minus 5 is 0. Okay, so that worked out perfect. For number 3, thought we might change it up a little. And let's look at the cube root of 2x plus 3 plus 1 equals 2. Steps are basically the same. There's only one subtle difference. Instead of squaring it now, I have to cube it or raise it to a power of 3 because the index is 3. Okay, so going through the steps, same thing, isolate radical, so subtract 1. Cube root of 2x plus 3 is equal to the number 1. Now I'm going to raise it to that power of 3, or cube it. And 1 cubed, 1 times 1 times 1 is 1. I'm going to subtract 3. And divide by 2. I get x is equal to negative 1. Now yet again you could check this one. Take it, plug it in. Cube root of 2 times negative 1 plus 3 plus 1 has to be the number 2. I get cube root of negative 2 plus 3 plus 1 is equal to 2. Continue right here. So I get cube root of 1 plus 1 is equal to 2. Well, the cube root of 1 is 1. 1 plus 1 is 2. That works out just fine. Now, let's switch gears a little bit, going to number 4. Number 4 is going to look a little different. Let's talk about this. I'm going to go ahead and draw my 2-column format. This is my given. Now, go ahead and warn you, this problem is going to be a little bit longer than the last few problems. So if you're working these out on paper, trying to take notes, I'd make sure to leave yourself a good amount of room. Because, because these are going to end up with absolute value equations near the end that we're going to have to perform the split and then solve each one independently and then check our answers. So when I work the problem out, writing out every single step like I'm going to do on here, I took up a full piece of printer paper, 8 by 11, so I took up the whole page. So make sure you leave yourself plenty of room. So let's get started. First step is the same. We are still trying to isolate. This is a radical. It just looks kind of different. What you need to know, and I'm going to write it out here, is that any time you have, let's say, let's just use the one we have, x plus 1 to the 2/3. Well, this top number, if I can get my computer to work the way I want it to, this top number is an exponent. And the bottom number, that's your radical or your root. Okay, so what that means is we're technically, and we work bottom to top on these, is that we're taking the third root or the cube root of this, and then whatever we get from that, we're going to square it or raise it to a power of 2. Now, some people do go, okay, well, I'm going to square it and then cube root it. That's perfectly fine. It doesn't matter as long as you follow proper procedure. I always work bottom to top. So I want to cube root it, then square it. To me, for some reason, it's usually just easier. For example, if I were to give you the number, let's just say the number 8 to the 2/3. Two methods. I'm going to do the method in red to start with exponent. So over here, I'm going to square it first, then cube root it. So 8 squared, that's 64. And now I'm going to cube root it. That's 4. Now, I know this right off the top of my head because I've been doing this a long time. But a lot of people don't know right off the bat that the cube root of 64 is 4. Well, what people do know, we'll do it in blue. If I cube root 8, that's pretty easy. It's 2 times 2 times 2. And people know really quickly that 2 squared is 4. Just like they know usually really quickly that 2 times 2 times 2 makes 8, or the cube root of 8 is 2. Okay, two different ways of doing the problem. Both come up with the exact same answer. But I followed this method over here generally because to me it just makes a little bit more sense and it's a little bit faster when it comes to calculation when I don't have a calculator. Okay, so we're going to be following those little bit of rules. One other thing we need to make sure we pay attention to, and I'm going to explain this in more detail here in a minute, is that if one is even, so if one of those numbers is even, that's when we're going to get absolute values. Only when one of those is even. And you're going to see why here in just a moment. But I wanted to go ahead and bring these two things up before we got fully started. All right, let's go ahead and get radical by itself. Divide by 3. So I get that x plus 1 to the 2/3 is the number 4. All right, now that I've done this, here's where I got to deal with this radical. The way we do that is I raise it to the inverse power. So I'm going to take this, x plus 1 to the 2/3, and I'm going to raise it to the inverse of this, or the reciprocal, 3/2. What I do to one, I do to the other, just like we've always done. By doing this, these are going to cancel each other out. 2 times 3 is 6, 3 times 2 is 6, 6 divided by 6 is 1. Boom. Exponent of 1, just like we've been doing the whole time. And this is what I'm talking about, this rule over here, this one. If these come out to be one of these sets are even, which if it starts even, the other one's going to be even as well, this is where absolute value happens. Okay, now over here 4 to the 3/2, just like we did with the 8. In this case we've got to square root, because the number on the bottom is our radical, so square root, then raise it to a power of 3. Well, square root of 4, I'll do it over here, square root of 4 is 2, and 2 to the 3rd power is 8. go ahead and write out your steps here. Raise to 3/2 power. Go ahead and write a little note. It was even, so that gives us an absolute value. And then here we simplified. Okay. Now that I've got an absolute value equation, this is where we perform what we called when we were in class back in chapter 1. That was a long time ago, back in like August and September. We performed what we called the split. That means I'm going to get two equations and have to solve them. The first equation looks just like this one without absolute values. X plus 1 equals 8. The second one looks just like this one, except the 8 is negative. So remember we talked about in class, absolute value is a distance. So we're trying to say, if I was looking at maybe the number 0, negative 8 out here, 8 over here, well, it takes 8 steps to get from 0 to 8. It also takes 8 steps to get from 0 to negative 8, just two different directions. So that's why we have to set up these two equations. Now I'm going to solve each equation by subtracting 1. And I get that x equals the number 7 and x equals the number negative 9. Okay, now that I know these, I need to do a check just to make sure we have the right answer. So I get that we have the original equation 3. I'm going to plug in my 7. 7 plus 1 to the 2/3 power has to equal 12. At the same time, I need to try that 3 times negative 9 plus 1 to the 2/3 power is 12. So I need to check both of these. Well, 7 plus 1, that's the number 8. 8 to the 2/3 power, that means I cube root and then square. So 8 cube rooted, that's 2. 2 squared is 4. 3 times 4 is 12. So 12 equals 12. That's good. That's correct. Over here, negative 9 plus 1, well, that's negative 8. Negative 8 to the 2/3, still cube root it and square it. So negative 8 cube rooted is negative 2. Negative 2 squared, that's 4, since we're in parentheses. And 3 times 4 is 12. Well, that's correct. So both of these produced correct solutions. Okay, problem number 5. Is 3/5 root of x plus 1 cubed plus 1 is 25. Now this one looks a little different, but once we go through some of the steps, you'll see that it's very much the same. It just looks different. Works out the same way. So I still have the given. I subtract 1. Still want to isolate that radical. I'm going to divide by 3. Since we have this set up, now I want to do what I'm going to call convert. I'm going to make this look like what we were doing in the last problem. Remember I told you that when I write these, such as x plus 1, when we had the 2/3, that the bottom number was root, the top number was exponent. Okay, well, my root is 5, and my exponent is 3. So that means I really have x plus 1 to the 3/5 power. Okay, exponent on top, root or radical on the bottom. Now I'm going to solve it. Just like we did with the 2/3, we raised it to the 3/2. I'm going to raise this one to the reciprocal, which is 5/3. And radicals cancel off. Now 8 to the 5/3. 8 cube rooted is 2. Raised to the 5th power is 32. Question, do I need absolute values? Answer is no. Looking at these, 3/5, 5/3, none of those numbers are even, therefore we don't have to worry about absolute values. And then we solve, we subtract 1, I get x is equal to 31. Now we can go through the process of checking this one. This one will come out just fine. It'll work out to be 8. I mean, whatever, come out to be 25. So we plug it back into the original. Question, why do we check these? You know, I can see that a few of you are probably thinking, well, why do I keep checking all these questions? If they're just going to keep coming out to be the correct answers, what's the point in checking them? In some cases, and we're going to have a few of those here shortly, like question number 7, we're looking for what we call extraneous solutions. Okay, looking for extraneous solutions. Extraneous solutions are solutions that pop up when we solve questions. You solve them just algebraically, following all the correct rules, making sure we're adding and subtracting, using our negatives, everything like that. And we'll get 2 answers. And we'll think, oh, there's 2 answers to this question. But then when we go through the check process, we turn out that one of them works, the other one doesn't, or sometimes both of them work. You know, that does happen. But the reason why we check is because sometimes solutions that we get when we follow all the rules of algebra perfectly fine, we find answers that are not actually answers. And that's why we call them extraneous solutions. They're solutions we get, but they're not actually solutions. So it's important to check your work, check the answers, make sure they come out and work just fine. This one does. You don't have to go through checking it. It does come out and work just fine. All right, I'm going to give you a question, question number 6, for you to try on your own. 2x plus 3 to the 2/3 equals 8. So try this question out, solve it, get your answers, and then come back to me. Okay, hopefully you solved it. For those of you that are not going to stick around to watch the solution, you're just ready to move on to the next part of the video, go ahead and tell you it is x equals -5 and 11. That would be the 2 answers. Oh, I wrote those backwards. Sorry about that. 5 and -11. Just go ahead and write this 5 and -11. Read my notes a little bit wrong. Sorry about that. So for those of you that are sticking around to see the solution, first thing, I'm not going to do the 2-column proof. I'm just going to go through the steps. I'm going to divide by 2. That leaves me x plus 3 to the 2/3 equals 4. Remember that we raise them to the reciprocal. And because we have even numbers here, we have absolute value. 4 to the 3 halves means a square root then cube. So square root of 4 is 2. Cube it is 8. Perform the split. One of them's positive, one of them's negative, and we solve. X is equal to 8 minus 3 is 5, and negative 8 minus 3 is negative 11. And if we go through the check, we will get that these are both valid solutions. Okay, moving on to number 7. Like I said earlier, or at least I believe I said it, I've had to record this video twice due to technical issues, but we only have 10 problems. This is problem number 7, and we have 8, 9, and 10, and we are done. Alright, now we're going to move on to variables on both sides. So I have x plus 7 minus 5 is equal to x. So I have variables on both sides. This is my given. Same thing as before, I want to isolate radical. So square root of x plus 7 equaling x plus 5. Now, same thing as before, I'm going to square both sides. And over here is where we're going to run into having to use the FOIL method or the double distribute, whichever method you perform. They really are the same thing. Or if you know the trick, there is a trick for this. It's a perfect square trinomial. So you can actually just square the first, square the last, multiply the two and double it, and you'll get the trinomial that you need. But whatever method you use is fine. I'm going to use double distribute since that's the method that most of you are familiar with. And I want to make sure we understand also that this does not equal this. Okay, these are not the same thing. Okay, that's why you have to use FOIL or double distribute. So this is where we squared both sides. And now we're going to simplify. X plus 7. Over here we're going to double distribute. X times x is x squared. X times 5 is 5x. 5 times x is another 5x. 5 times 5 is 25. Now I write mine a little differently than most of you do. I write mine where my terms are lined up and down, so I can just add and subtract from top to bottom. To me, it just seems more appropriate. Just a matter of preference. 5 and 5, that's 10. And then I've got 25. So this part here, that's your FOIL / distribute / simplify. Okay, so that's what we did there. FOIL, distributed, and simplified. Now we want to solve for x. I'm now dealing with a quadratic. I've got an x squared term. That means I'm dealing with quadratics. So I need to get everything to one side, get it equal to 0. So I'm going to subtract x. So 7 is equal to x squared plus 10x. Oops, sorry about that. 10 minus x, that's 9x, plus 25, minus 7. So first we subtract x, and then we're going to subtract 7. So I've got x squared plus 9x plus 18 is equal to 0. Now once we get to this step here, we now have to factor. That's one method we can use. We could factor. Or we could use the quadratic formula. Remember quadratic formula, negative b plus minus the square root of b squared minus 4ac all over 2a, and that's x equals. So I could use this. If you're more comfortable with this than factoring, that's fine. I'm going to go through and factor. This one factors very nicely. Remember, if we factor, so let's go ahead and draw that like that. So we're going to say we're going to factor. Make me some room. We take the term c, we're 18, and we write down every number that multiplies to make 18. That's 1 and 18, that's 2 and 9, 3 and 6, 4 no, 5 no, 6. We already got it, so we're done. So these three sets multiply to make 18. Which of these three sets add to be the middle term 9? Well, it's 3 and 6. And since we don't have a leading coefficient greater than 1, we're going to write our factors just like we see them, x plus 3 and x plus 6. Very easy to do, very simple. Now if I were to FOIL this out or double distribute, I'd get back to this, so don't try to do that. At this point, we set each factor equal to 0. So x plus 3 has to equal 0, and x plus 6 has to equal 0. And we solve. So I subtract 3, I subtract 6. So I get x is equal to negative 3, and I also get that x is equal to negative 6. Well, here's the check. So I'm going to take and plug negative 3 over here. So I've got the square root of negative 3 plus 7 minus 5 has to equal negative 3. So I plugged in negative 3 for both of the x's. And this one I'm going to do in red. So we have the square root of negative 6 plus 7 minus 5 has to equal negative 6. Okay, on this side I've plugged negative 6 in for the x's. Now I'm going to solve. I'll start with this one first. So negative 6 plus 7, that's the number 1. Square root of 1 is 1. And 1 minus 5, that's negative 4. Well, negative 4 and negative 6 are not the same number. Therefore, x equals negative 6. That's not a solution. It's what we call extraneous. It's a solution that we found by solving, but when we plug it back in, it actually doesn't work. Now over here, negative 3 plus 7, well, that's positive 4. Square root of 4 is 2. 2 minus 5 is negative 3. Well, that one works. So negative 3, this does not work. Negative 3 is the only solution. This is why I've been telling you to check your answers. Okay, question number 8. You should try working this one out on your own. Square root of 5x minus 1 plus 3 equals x. Okay, so work this one out. Okay, hopefully you paused the video and now you're coming back to check your answer. Yet again, for those of you that are just here to just check your answer, x is equal to 10. So let's go through the steps. We subtract 3. 5x minus 1 is equal to x minus 3. Since we're talking about square roots, I'm going to square both sides. Over here, I have x minus 3 times x minus 3. So I do double distribute to get x squared, negative 3x, another negative 3x, and negative 3 times negative 3 is positive 9. So I get x squared minus 6x plus 9. Well, dealing with quadratic again, so I need to get it to 0, plus 1. Subtract 5x. X squared minus 11x plus 10 equals 0. Okay, need to factor. Looking at 10, I have the options of 2 and 5 or 1 and 10. I need to make negative 11, therefore I'm using negative 1 and negative 10, because those add to make negative 11 but multiply to make positive 10. No number in front of x, therefore I'm just going to write it like I see it, x minus 1 and x minus 10. So x has to equal 1 or x has to equal 10. Well, we know from the beginning of the video that I told, or beginning of this particular question, I told you that 10 is the only solution, 1 is not. Okay, so I'm not going to go through plugging that in. I think you can handle plugging it in. That way the video doesn't exceed a large amount of time, since we already have 2 more questions in it, 37 minutes. Okay, well, you have 2 more questions. The first of those 2 questions, question number 9. Okay, we've done up to this point, we've had square root equations, cube root equations, equations with the fraction exponents, and we've done equations with variables on both sides. Now the final type is, what if there's multiple radicals? What if it's not just one radical? What if I have square root of 2x plus 1 minus the square root of x equals 1? Now I have 2 separate radicals. Okay. We're still wanting to get radical by itself, but which radical? We have 2 of them. What is suggested is to get the most complicated radical by itself. To me, this looks way more complicated than square root of x. So I want to get this by itself. So I'm going to add square root of x to both sides. Okay, so I've added the square root of x. Now that we've got this accomplished, we need to square both sides. So over here we get 2x plus 1. Over here we do not get x plus 1. Okay, so we need to actually FOIL this one out here. So the square root of x plus 1 times the square root of x plus 1. So let's do FOIL, or double distribute. Square root of x times square root of x, we know when we do that, the square roots drop off, we just get x. Square root of x times 1. Well, that's the square root of x. 1 times the square root of x is another square root of x. 1 times 1 is 1. That means we have x, we have two of these square root of x's, and I've got plus 1. Now I've got a radical here. I want to get rid, or basically get this radical by itself. Let's move x. And we'll subtract 1. Now, I don't have to divide by 2 here. I can, but then I'm going to have a weird fraction over here. Instead, I'm going to square both sides again. So I get x squared on that side. And over here, since I have two terms, I have to, or two items, I have to square them both. So 2 squared made 4, and x, square root of x squared is just x. Well, I'm dealing with a quadratic again, so I need to get it equal to 0. And now I need to factor. This time there's not 3 of these, there's no c term, so I don't try to factor c to make the middle b. All I do is see what do these two terms have in common, and they both have x. Okay, now that I got them factored, set each equal to 0. So x is equal to 0, and x minus 4 is equal to 0. Solve them. That one's done. Add 4. X equal 4. Let's solve. Okay. Now that we got both, we need to check our answers. So we had, this is our check. So it's square root of 2 times 0 plus 1 minus square root of 0 equals 1. So that's the first check. Other check is square root of 2 times 4 plus 1 minus the square root of 4 equals 1. Alright, over here 2 times 0 is 0, so I've got square root of 1 and minus 0. That's 1 equals 1. That works out. Here, 2 times 4, that's 8 plus 1. 8 plus 1 is 9. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. So both 4 and 0 are both solutions. There are no extraneous solutions in this case. Alright, last one, number 10. Got 5x plus 4 minus square root x equal 4. Alright, I would pause the video and try this one. I will say this, when you work through this one, you'll get to a point where there's some pretty big numbers. Divide by 16 is going to be the hint that I'm going to give you on this question. Whenever you got it set equal to 0, divide by 16 before you try to factor. Let's go ahead and try to work this one. Alright, so I'm assuming you're back so you can check the answer. Answer for this, for those of you that just want to be done with this video since it's 45 minutes long at this point, x is equal to 9. Okay, so that's your check for those of you hanging around. I'm going to go through solving this one. Same thing as before. I'm going to add the square root of x. So square root of 5x plus 4 equals square root of x plus 4. I need to square both sides. So I get 5x plus 4 on this side. Over here, if I FOIL it out, I get x plus 8 square root x plus 16. Okay, that's this multiplied by itself. Go ahead and try to get this radical by itself. Subtract x. So I get 4x plus 4 equal 8 square root x plus 16. Subtract 16. 4x minus 12 equal 8 square root x. Square both sides again to get rid of the radical. Foiling this out, you get 16x squared minus 96x plus 144. This is what I was talking about with the big numbers. Here, I get 8 squared is 64, and then x. Got an x squared, get it equal to 0. I'm subtracting 64. So I get 16x squared minus 160x plus 144 equal to 0. And this is that hint that I told you before you pause the video. You would need to divide by 16 to make this a little bit more simple. So I get x squared. Here I get negative 10x. And here I get 9. This factors very nicely. X minus 9, x minus 1. Set them equal to 0. X minus 9 equals 0. X minus 1 equals 0. So x is equal to 9. X is equal to 1. Doing my check. Square root of 5 times 9 plus 4 minus square root of 9 is equal to 4. And over here, square root of 5 times 1 plus 4 minus square root of 1. Here I get 5 times 9 is 45 plus 4 is 49. Square root of 49 is 7. Square root of 9 is 3. 7 minus 3 is 4. So 9 works. Here I get 5 times 1 is 5 plus 4 is 9. Square root of 9 is 3. Square root of 1 is 1. I put 2 because I was hard doing the math. 3 minus 1 is 2. 2 and 4 are not the same. That one's extraneous. Alright, ladies and gentlemen, with that is all the problems I have for you on solving radical equations. See you in the next video.